Hi, this is Mrs. Schenck. We've been talking about the gas laws and we've been working up to this one. So today we're going to talk about the ideal gas law. The ideal gas law takes the other ones into account. It's really a combination of Boyle's law, Charles' law, and Avogadro's law. So the ideal gas law is derived by combining Charles' law, Boyle's law, and Avogadro's law. The equation for the ideal gas law is PV equals nRT. Unlike the other gas laws, you have to have very specific units for each part of this. That's because of R, the ideal gas constant. It's derived based on 1 mole of a gas at STP. So you have to use those units, moles, and then the pressure in atmospheres and Kelvin temperature, as well as volume liters. So here's our equation written with the right units. Pressure has to be in atmospheres, volume has to be in liters, moles, that's N is moles, and then temperature has to be in Kelvin. R is new, R is an ideal gas constant, and because you have to use that constant, that's why you have to use all these units as they are. The ideal gas constant is 0.0821 atmospheres liters over mole Kelvin. So as you can see, you'll be able to cancel out mole Kelvin and then divided by atmospheres liters. That's where this unit comes from for R. Okay, so let's look at some examples. A rigid steel cylinder with a volume of 20.0 liters is filled with nitrogen gas to a final pressure of 250 atmospheres at 27 degrees Celsius. How many moles of nitrogen gas does the cylinder contain? As always, it's your best practice to underline whatever you need to use. I would suggest pausing and doing that on your own before looking. So we've got volume, pressure, temperature, and then it's asking for moles, which is N. Notice there are no V1s or V2s here. We just have volume. So let's go ahead and look at how we're going to do this. We'll use PV equals nRT. We need to solve for N. So think about your algebra. How would you solve for N? You always do the opposite of what's being done. Right now it's N times R times T. What's the opposite of multiplying? You're going to divide by RT on both sides. So when you divide, you end up with getting rid of the RT on this side, so N by itself equals PV over RT. When you plug those in, you've got 250 times 20.0 over the 0.0821 constant times 300. Of course, I did 27 plus 273 to get that 300. And when I divide that out, that's equal to 160 moles if I use my two significant figures, because my lowest amount of sig figs is 2. That's from that 250 right here. Also, I do want to point out to you, since you have more than one thing on bottom to divide by, it's good practice to do 250 times 20 divided by parenthesis 0.0821 times 300 and your parenthesis. That'll avoid getting the wrong calculation if you use those parentheses. Example 2, see what you can do with this. Pause and try it. So you might have noticed this time it asked you to solve for grams. Grams was not part of our equation. However, grams is very closely related to something in our equation. Moles. So if I know the number of moles, I can calculate the number of grams. So I'm going to use the ideal gas law to find the number of moles. Then I'm going to use that later to find grams. So we're going to start with N equals PV over RT, which we derived from the last problem. When I plug it in, 15 times 2.24 times 10 to the 6 over 0.0821 times 315. Again, you might want to divide with parentheses. Okay, I didn't round here. The reason being is because I don't have my final answer yet, and I usually try to wait until I'm down to my final answer before I do any rounding. So I've got this big number. Now I have to convert this into grams. We've done this a lot of times. This is just our good old mole map problem where we put moles on bottom, grams on top. In this case, it's 16 grams because it says methane. And if you've forgotten, methane is CH4. Okay, so that's 1 carbon and 4 hydrogens. Carbon's mass is 12. Each hydrogen is 1 times 4 is 4. So that's 16 grams. And we get, with 3 sig figs, 20,800,000 grams. It's a lot of grams. All right, let's look at example 3. Try it on your own first. See anything unusual there? Okay, we're looking for volume this time. We have temperature and pressure, and we have grams. Again, grams is not part of our equation. However, grams and moles are easy to convert between. So if you have that 3,600 grams, you can convert that into moles. The GFM 44 came from the C3H8, so that's 12 times 3, 1 times 8, so 36 and 8 is 44. Okay, so this time we want to solve for volume. So volume is being multiplied by P. I'm going to do the opposite of multiplication, so I'm going to divide both sides of the equation by P. P is going to cancel out on the left side, so we just have V equals nRT. And then we're ready to just plug everything in. So the N that we calculated from the 3,600 grams is 68 moles. Times R is the 0.0821 times temperature 25 plus the 273 gives us 298 over pressure is 3. How many sig figs are we going to want here? 2 sig figs gives us 560 liters, and that's the ideal gas law.